With hundreds of thousands of personal UAVs currently in public hands, the question of will a serious drone strike on an aircraft occur is no longer a matter of if, but when in the minds of many experts. While tests on bird strikes have been conducted for decades, what kind of damage a drone would cause was still virtually unknown until now. Researchers at the University of Dayton Research Institute are no strangers to airframe impact testing, and they recently partnered with Sinclair College National UAS Training and Certification Center to determine what could happen to a general aviation aircraft if it hit a recreational drone in midair.
We wanted to demonstrate what the hazards are, or the risks, or potential risks are with a drone strike on an aircraft. There's very little data out there to help people understand what happens. So there has been other types of this type drone testing, but it's been individual components. So they've tested batteries, motors, cameras, and launched them into panels, but not actual aircraft structures.
This test was to see what would happen if an entire drone struck the leading edge of an airplane wing.
So the drone we use for this type of testing is a DJI Phantom 2. And that's a very popular drone out for hobbyists.
It was loaded into the university's Impact Physics Lab's compressed air cannon, which would fire it at the wing of a Mooney M20 at a speed of 238 miles per hour, a speed that approximates the closing speed between the two aircraft.
The drone did not shatter apart. It completely penetrated and it was buried inside the wing. You can see a hole in the leading edge here. The main spar is dented. There's several fasteners that are pulled from the spar from the wing skin. There's some stringers that are bent. There's also some tubing inside.
And just keep in mind, that's primarily plastic. There's very little metal on those things, on remote vehicles.
That was also bent. So there was a substantial amount of damage to the wing.
While Poorman believes the aircraft would have survived the impact, he also believes that for a faster aircraft, the results could have been worse.
Yeah, if this was a business jet that was traveling twice as fast as what we tested, there would have been substantially more damage to the spar, or could have penetrated a fuel cell, because the energy goes up with the square of the velocity.
Poorman has performed simulated bird strike testing for nearly 30 years, and he tested to see what damage a similar-sized bird might cause under the same conditions.
To compare the impact of the drone strike to an actual bird strike, we did a simulated bird using a gelatin projectile that had the same weight and it was approximately the same speed. The bird actually just crushed the leading edge and didn't do any internal damage. As the drone population increases, the likelihood of these kinds of events.
So why am I showing you all this? Because if a little plastic remote toy can do that,
This week is traditionally the peak of hurricane season. We're doing a series of reports we call the Eye of...
Working on either side of the Atlantic, two renowned scientists, Frank Greening and Christian Simonson, are challenging the official 9/11 report into the collapse of the Twin Towers. They believe that by ignoring the presence of aircraft wreckage in the fires, the report missed the true cause of the collapse, one of the most potentially explosive metals on Earth, aluminum. Softer, lighter, and more flexible than iron and steel, it's the ideal material for building aircraft. Under normal conditions, this incredibly flexible and versatile metal is entirely safe, but in extreme circumstances, aluminum can become incredibly volatile. One of those circumstances is when the metal is molten. Molten aluminum is safe. until it comes into contact with one of the most common molecules on the planet, causing a highly explosive exothermic reaction. That abundant substance is water. When water comes into contact with molten aluminum, the water molecules recombine, producing aluminum oxide and hydrogen, releasing an explosive amount of energy. Frank Greening and Christian Simonson believe they have found the answer to some of the questions left unexplained by the official report. The theory goes like this. Inside the burning floors, the building debris collects to form an insulating wall around the aircraft wreckage, creating a furnace. Inside, the aluminum reaches 1,000 degrees. At 700 degrees above its melting point, the aluminum now flows like water. Finding cracks and holes in the damaged floor, the molten metal lands in pools of water from the sprinkler system on the floor below. The theory could explain several of the questions unanswered by the official report, including the explosions heard by 118 firemen. If enough aluminum reacted in a single event, it would provide enough force to damage the steel supports sufficiently to weaken them.
That is amazing. When did this come out? And why is no one talking about this in the 9/11 community? Never heard of this. They're trying to explain the nanothermite and everything. Hold on a second.
The answer is blowing. How many years must one man have?
And here is the action as seen from the front. The initial barriers destroy the propellers, separate the landing gear, wrench the engines from their mounts and start engine fires. The pole impact yaws the aircraft. There is a glancing contact with the left wing. The aircraft is pitched up, and the fuselage, weakened by the propeller, fails. There is severe crash impact on the second hill. The fire, which is so impressive in this slow motion photography, in reality is lasting only through the 5-second crash sequence. It consumes 15 gallons of fuel carried in the right-hand wheel well and most of the engine oil. Actually, there is no fire damage to any part of the aircraft. And here is a detailed view of the right wing. The 12-inch telephone pole cuts off the outer panel, but the heavier inboard section breaks off a larger 13-inch telephone pole. The basic wing structure remains intact.
Yes, before they're allowed to be free. And how many times can a man turn? And how many times can a man look up before he can?
So, from my understanding, there is no way that the tips could be damaged or could cause that damage. Right in here, yeah. Those, the tail fins. No. This guy? No. Can't. So, I hope y'all can actually see that, how badly we've been lied to. Take care, be safe, be kind, stay strong. I love y'all. And stay tuned. Gonna be traveling.